In this lecture, we are going to see some bookworks based on analytic function. If f of z equal to u plus iv is a regular function of z equal to x plus iy, then prove that del square of modulus of f of z square equal to 4 times of f of z square. So del square we know that it is dou square by dou x square plus dou square by dou y square times modulus of f of z square equal to 4 times of f dash of z square. So what is f of z? U plus iv. What is the conjugate of it? U minus iv. Now by doing the product of these two, you are going to have u square plus v square. So modulus of f of z square you will get as u square plus v square. Therefore, here del square into modulus of f of z square equal to dou square by dou x square plus dou square by dou y square of u square plus v square. So what we are going to do here is, we are going to differentiate u square plus v square with respect to x partially and with respect to y partially. So dou square by dou x square of u square plus dou square by dou y square of v square and dou square by dou x square of v square plus dou square by dou y square of u square. So what is dou by dou x of u square? It will give you 2 times of u into ux. Again, if you are differentiating with respect to x, you will get dou by dou x of 2 times of u into ux equal to, you have to use product rule. Differentiating u, you will get ux square, and differentiating ux again with respect to x, you will get dou square u by dou x square. So you are going to have 2 times of u into dou square u by dou x square plus 2 times of dou square u by dou x square. Likewise, you can able to write dou square by dou y square of u square. That gives you 2 times of dou square u by dou y square plus 2 times of dou square u by dou y square. Then you are going to substitute it in this formula. So here in the place of dou square by dou x square of u square, 2 times of u into uxx plus 2 times of ux square. This term is going to be 2 times of u into vuyy plus 2 times of uy square. Similar manner, you can differentiate v square with respect to x 2 times and with respect to y 2 times. You will get the answer, and by doing the addition of it, okay, you will get it as here dou square u by dou x square plus dou square u by dou y square is equal to 2 times of u into dou square u by dou x square plus dou square u by dou y square plus 2 times of dou square u by dou x square plus dou square u by dou y square. So uxx plus uyy equal to 0 because it is satisfying the Laplace equation. F of z is an analytic function. So you are having this term, first term is going to be 0, ux square, and by applying the Cauchy-Riemann equation, ux equal to vy, uy equal to minus vx, so minus vx the whole square. Therefore, from this, you are getting 2 times of ux square plus vx square. What is this? It is nothing but modulus of f dash of z square. So, in a similar manner, you are going to get dou square v by dou x square and dou square by dou y square of v square gives you 2 times of modulus of f dash of square z square. Here, in this place, you will get dou square u by dou y square and dou square v by dou y square you will get. So that also you can write it in this manner. Therefore, by adding the two equations, you are going to have 2 times of modulus of f dash of z square plus 2 times of modulus of f dash of square is 4 times of modulus of f dash of z square. Hence, we proved. Now, we'll see this problem. If f of z equal to e power x into cos y plus I sin y is analytic function, prove that u and v are harmonic functions. That means you have to show that dou square u by dou x square plus dou square u by dou y square equal to 0 and dou square v by dou x square, dou square v by dou y square equal to 0. So just find out the real part and imaginary part from f of z. So f of z equal to e power x cos y plus I into e power x sin y. Therefore, real part is e power x into cos y. Imaginary part is e power x into sin y. Get the first order differentiation of u is e power x into cos y. First order differentiation of v with respect to x is u power x into sin y. Differentiating again with respect to x, you will get e power x differentiation is e power x itself cos y, and differentiating v again with respect to x, e power x is e power x itself into sin y. Likewise, you have to find dou square u by dou y square and dou square v by dou y square. So we are getting this. Now, by adding dou square u by dou x square, you can see this plus dou square u by dou y square. See here, by adding these two, what you are going to get? You will get the answer as 0. Likewise, by adding these two, you will get the answer as 0. Hence, u and v satisfies the Laplace equation. Therefore, u and v are harmonic functions.